This is number 54 in section 3 of chapter 6. The problems at the end of the chapter. It's given the following data. You have these three reactions and the delta H's for those reactions. Calculate delta H for this overall reaction. All right, so we need to calculate the delta H for this reaction here. Now, we don't know this, obviously, that's why we're solving for it. But we do know the delta H of these three equations. And we know through Hess's law that the summation of the delta H's of all these reactions that result in this is going to be the delta H of this, because it's a state function. Doesn't matter how you get there. The sum of these steps should equal the overall function, the overall movement or process. So what we're going to do here, and like I said, we need to combine all of these equations in such a way that they result in this equation. The way we do that, or at least the way my eyes fall to it, is I look at the reactant first. Or, I'm sorry, not reactant, I'm sorry, product first. For whatever reason, it's what I do. So this is C2H2. And where in these three equations do I find H2, or sorry, C2H2? First equation, reactant side. Well, I found it, but it's on the wrong side. So what do I have to do? I have to flip the equation. So I'm actually going to draw the reverse reaction of this, and I will have to take the positive value of this delta H as I use it later. So let's go ahead and draw that, the reverse reaction here. So 2 CO2s plus H2 reacts to yield C2H2 plus, let's see, oh, yep, that's it. I'm sorry. All right, and this will now have delta H of a positive 1300 kJ. So I have accomplished getting C2H2 on the product side. I'm sorry, but I have this this O2 as a product as well. So I want to try to get rid of this O2 over here. Now it's 5 halves, so it's 2.5. 2.5. I have a half. I have 1, so I have 1.5 total. I need 2.5 total. So that would allow that to cancel out, but I'm going to have to double how much oxygen I get from this middle equation. But because I do that, because I'm doubling the amount of stuff in this reaction, I'm doubling this reaction, I need to double the amount of heat that is generated. So I'll multiply this delta H by 2. Now, as I do that, I'll end up with 2C plus 2 O2s. That'll react to yield 2 CO2s. And we'll have a delta H for that one of, let's see, negative 394 times 2, negative 788 kJ. All right, so with these intact, with these oxygens intact the way I've drawn them here, I have 5 halves of an O2 molecule on the reactant side and on the product side, so those will end up canceling out. Now, so that'll take care of the product side here. Now, as a result, as well, I have this CO2 on the product side, which you can see here. I don't want any CO2 on the product side. But I have 2 CO2s. I have the same number of CO2s on the reactant side. And so those will cancel out. I don't have to worry there. So as I bring this H2 plus half O2 and a water down, I can check before I do it. I'll have H2 on the reactant side, which I want. You can see it here, which I want. And I will have 1 water on the reactant side, but that'll cancel with the water on the reactant side, so that'll take care of that. So H2 plus 1/2 O2 reacts to yield H2O. with a delta H of negative 286 kJ. Now let's do some canceling and see if we come up with our final reaction. Remember, as a result, after I cancel these things, I should end up with this final equation up here. So I have two O2s on each side of the reaction arrow, therefore they'll cancel out. I have a total of 5 halves, okay, 5 halves of O2 on either side, so those will cancel out. I have 1 water on either side, so that'll cancel out, and you can see I have 3 species left. I have 2 carbons, an H2, and my C2H2, which is what I want. So I have accomplished a series of reactions that will give me my final reaction. C2H2. And what that means is the way I've set these up and manipulated these equations and thereby manipulating these delta H values, I can simply sum these values and have the delta H for this overall reaction, which is what the question is asking for. So, final step. So I'll go positive 1300 plus negative 788 plus a negative 286. And I will end with a 226 kJ value, and that is a positive kJ value, meaning this is going to be an endothermic reaction, but that's not what I'm being asked. I'm being asked for the delta H for this reaction, and the delta H for the reaction is positive 226 kJ.